another session. I'm so sorry. Another session on number system. Previously, we have learned how how to convert the given rational number into decimal, and how the decimals were either getting terminated or they were not getting terminated. And in the case they were not getting terminated, there was we came across a case where it was recurring as well. We also would come across steps wherein it becomes non-recurring, but we need to know that a decimal expansion, when is terminating or it is non-terminating recurring, both the cases they represent rational numbers. That means it is terminating or non-terminating recurring decimal expansions means they are rational numbers. Oh, I may have mistaken writing rational number. I rectified it. Now let's see questions under that one. Suppose there is a question which says represent 0.3 and there's a bar, that means repeating 0.3333 and so on. We have to show that it can be expressed in terms of 3. Show that it can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0, where P and Q are integers and Q isn't equal to 0. So we don't know actually how to represent 0.3 bar, so let us call x as 0.3 bar. Writing 0.3 bar is equivalent to if I write 0.333 and so on. Now I multiply 10 to both the sides. So when I multiply 10 to both sides, I'm getting 10x this side, and on this decimal representation now becomes 3.333 and so on. Now this 333 so on can also be represented as 3 plus x, because 3.33 is also 3 plus 0.33 and so on. In that case it becomes 3 plus x. Now if we solve and I take 10x minus x is equal to 3, and oh god, I made a mistake. I should be carrying x to the left. That's giving me 9x is equal to 3, and x then becomes 3 by 9, that is equal to 1 upon 3. So now x has been successfully represented as 1 by 3 in the form P by Q, as Q is not equal to 0. Let's take up one more similar question for a better understanding. I'm not writing the whole question, we'll simply try to follow the whole setup with 0.1 bar. That means I will be taking up 0.1111 as a decimal representation. Again we follow the same way. We assume x to be 0.11. I multiply 10 to both the sides, so I'll be getting 1.11 and so on. This 1.11 will again be taken up as 1 plus x, because we took this 0.11 as x. Same logic as the first question. I carry x to this left side and I'm left with a 1. This is 9x equals 1. So x equals 1 by 9. That was not that difficult. We now move on with a similar representation of another number. We take up to show 1.2727, that can also be written as 1.27 bar. Here is as now supposed to be expressed as p by q form, where p and q are integers and q is not equal to 0. Here, as because in the previous questions I had taken 0.1 bar, 0.3 bar, that means there were only one digit getting represented. I multiplied both the sides with a 10. Here in this particular question you can see 27, there's a 2 digits are getting repeated. So we take, though this as x, will be multiplying 100 to both the sides. So my number becomes 100x is equal to 127.272727, and it continues. Again, the same type of representation we made. This can be segregated and written as 100 plus x, thereby carrying x to the left makes it 99x equals oh, I made a mistake. I didn't take sorry. I need to just make some corrections. I had taken 1.27 as x, so this will be 127 minus 1.627, so it is 126 plus x. Then only I'm getting 127. X is represented as 1.27. Yep. So now sorry, I carried this to the left, and again the same 126, it's 99x is equal to 126. If I have to find x, 126 by 99 can be reduced and divided by 3. That's giving me 33, and then 42, 12. Again it is divisible by 3, that's giving me 11, and 114. So 1.27 bar, if represented, is 14 by 11. We can take up one more such question wherein 2 digits are getting repeated. What question do we take up where 2 digits are getting repeated? I have already taken 1.27. Let us take up 0.35 bar. Again the 2 digits are getting repeated here. I will take up again x assumed to be 0.353535, and in continuous, as because there are 2 digits getting repeated, I multiply both the sides by 100, so it is 100x is equal to, now it becomes 35.3535. How is now this going to be represented? Because I have already taken x as this, so it is 0.35 subtracted, so it's 100x is actually equal to x plus 35. That would give us 35.3535. x has been assumed to be this. I again carry x to the left side, that would make 100x minus x 99x, and this is equal to 35. So x can be now represented as 35 by 99. Now next comes where you have 3 digits getting repeated. Like I take up a question which says it is 0.235 or 2. No, I will not. Acha, there are two types of representation even in the 3-digit repetition. One being the simple one like 585 getting repeated. You might also come across questions like the second after 1 digit then 2 digits get repeated. We'll take this type questions in the next session maybe. Here we take up with 3-digit repetition. Here 3 digits getting repeated, so I take x as 0.585585 and so on. I multiply 1000 to both the sides, so it is 1000. X is equal to 585.8585 and so on. Now this can be represented as 585 plus x. I again carry this x to the left, that makes 1000, x as 999, x as 585. Thereby I'm giving x to be 585 by 999. In the next session we will be taking up representation of this number, or I think I've been taking up or maybe the one like or this is the one different last type of representation which we are left with. So we take up this such question in one of the next sessions. Thank you.